This steel box did not merely carry the modern world, it forced the world to rebuild around it. Ports moved, ships changed shape, waterfront jobs disappeared and new ones appeared. Factories spread across borders, and objects made thousands of kilometers apart began arriving as parts of the same product. But the strange thing is this: the box itself was not a technological miracle. It was corrugated steel, strong corners, and doors. So how did something so ordinary reorganize global trade? Before the modern container, much general cargo traveled as separate pieces. A shipment might leave a factory in crates, be unloaded from a truck, stored near a dock, lifted into a ship's hold, packed around other cargo, then handled all over again at the destination. Every transfer consumed time, every shape needed a different plan. Rain could stop work, a mistake could damage a crate, a missing item could disappear into a maze of warehouses and manifests. This was called break-bulk shipping, and the bottleneck was often not the ocean. It was the boundary between land and sea. People had tried putting freight into boxes before. The difficult question was not, can cargo go inside a container? It was, can the same container travel through an entire system without being opened? In 1956, trucking entrepreneur McLean helped stage the voyage that became the symbol of the modern container era. A converted tanker called the Ideal X sailed from Newark to Houston, carrying 58 large cargo containers. The operating idea was brutally simple: separate the cargo box from the truck's wheels, lift that box onto a ship, then place it on another chassis at the far end. No unloading every carton at the dock, no rebuilding the shipment inside the vessel. The cargo would cross the old boundary as one unit. McLean did not invent every form of container, and the Ideal X did not create a global network overnight. His early boxes were not even the dimensions that would later dominate world trade. The voyage proved possibility. It also exposed the next problem. What happens when every company builds a different box? A container owned by one operator had to fit another company's crane, a railway wagon, a road chassis, a ship's cells, and the container stacked above it. If the dimensions, strength, or lifting points disagreed, the entire promise collapsed. The real breakthrough was not a box. It was agreement. In 1961, the International Organization for Standardization created Technical Committee 104 for freight containers. Its work covered dimensions and ratings, but also stacking, terminology, and the fittings that let a crane grab a box and twist locks secure it. McLean's relevant patents were made available to ISO free of charge. C3, C4. Those corners became a physical contract. Build to the shared interface, and your machine could join the network. Safety needed its own international contract. Rapid container growth led the International Maritime Organization and the United Nations system to develop the 1972 Convention for Safe Containers. It set common testing and strength requirements. A safety approval issued by one contracting party could be recognized by another. Now a box could cross borders with fewer incompatible checks, not because everyone trusted the owner, but because they trusted the standard. Then the box began rebuilding everything around it. Old cargo piers were designed for ships beside warehouses and armies of people moving individual loads. Container terminals needed a different geometry: broad paved yards, giant cranes, stronger quays, deeper berths, fast road and rail links, and computer systems that knew where each nearly identical box was waiting. The work changed too. Containerization sharply reduced traditional piece-by-piece dock labor, but it demanded crane operators, mechanics, planners, drivers, software, customs data, and enormous capital investment. The ship became a grid. The port became a sorting machine. Cargo became information attached to a standard object. From the late 1960s Through the 1970s, fully cellular container ships expanded, and conventional general cargo liner shipping retreated. But why would that reshape life far from the coast? Because manufacturing no longer had to sit beside one source, one port, or one market. A sealed load could leave a factory by truck, transfer to rail, cross an ocean, return to road, and reach a warehouse without the goods being individually handled at every step. The container did not eliminate distance. It made the handoffs across distance more predictable. UNCTAD puts the consequence plainly. Globalized production, as we know it, would not have been possible without containerization. That does not mean every traded object travels in a box. Oil, grain, and ore often move in specialized bulk systems. But for manufactured goods, components, and countless consumer products, the container became a shared unit of movement. In 2021, ports worldwide recorded 1 million TEU of container throughput, 43% more than a decade earlier. 1 TEU represents the volume of a standard 20-foot container. The figure counts handling events, not 851. 1 million unique boxes. The same container can be counted at multiple ports. Even with that caution, the scale is extraordinary, and the efficiency created a new vulnerability. When a terminal slows, a ship misses its window, or inland transport fails, the disruption can travel through fixed schedules and tightly connected production plans. Poor performance at one port can disturb an entire route. The box made the system faster by making every link depend on the next. That is the hidden power of the shipping container. Not steel compatibility, not one inventor's flash of genius. A long, difficult conversion of ships, ports, laws, labor, machines, and data to one shared language. The container could move anywhere, only after everywhere changed to receive it. The object that rebuilt the world was designed to disappear into the system.